right, this video is going to talk about how to graph sine and cosine functions. We're going to talk a little bit about shifting in this video. Now, first thing we want to remember is sort of the details of how we handle the period and the amplitude of a sine and cosine function. Because again, shifting is just going to be sort of an additional thing beyond those two ideas. So first of all, let's just do a quick review problem here. If we're talking about a cosine function, remember that we sort of called these numbers that are in here a if it's multiplied in front, right? The leading coefficient, we would call that a. And again, if there's anything multiplied inside, we have a tendency to call that b as far as our formula goes. Again, we'll show you the formula here in just a minute. But if a is -6, that's going to tell us two things. Number one, it's a vertical reflection. Right? We're going to have a vertical reflection. So we're going to actually start, again, cosines normally start at their maximum. We're going to start at a minimum. And again, the amplitude, right, is the absolute value of a. So again, the amplitude for us, absolute value of -6 would be +6. So again, when we think about where we would start a cosine function, normally we would have started up at +6. But again, we're going to start down here. We're just going to call this -6. We're going to start right on the y-axis there. Now, normally we go 4 tick marks down the road, right? And we would, again, end at that, also at that minimum. Halfway in between, right, or what would be +6 for us, we're going to be up here at a maximum. And again, those sort of quarter marks, if you will be right on equilibrium, right on the x-axis. So again, we can actually graph our function, right, by just making sure we hit those major sort of 5 points that we just plotted, right, from beginning to sort of equilibrium to the top, equilibrium again, back down to the bottom. Now, notice we don't have any scale on the x-axis yet, so that's not a good thing. We need to remember that, again, that's where that pi comes into play here, that b value. Again, the period of our function, the full width of one phase of our function, is going to be equal to 2 pi divided by b. So again, 2 pi over pi, it's actually just going to be 2. And again, we would call this value, right, that last tick mark value then, that's going to be a 2. So really, these quarter marks are at the 1/2 mark, because halfway we would have been at 1. This would have been 3 halves, right, or 1.5, and we would have been all the way up here at 2 when we ended that first period, right, that first phase of our graph. Now, a and b are not the only two changes we can make to a function. Again, if we add or subtract, we can also make things shift. Now, adding outside of our function is probably the easier of the two. That's a vertical shift. So what's going to happen is our maximums, our minimums, and really our equilibrium is going to move depending on what this d, right, what number we add on the outside, what this value would be. It sort of resets the equilibrium, if you will. So again, 1 plus the sine of x means that now we're sort of centered, right, 1 unit up, right, at y equals 1. And now we went 1 unit up and 1 unit down, right, the amplitude up and the amplitude down from equilibrium, from that middle. The same thing goes for the cosine. It would again go up and down from equilibrium. Notice the example on the right here, though. We're not adding or subtracting outside, we're subtracting inside. And again, anything inside is sort of backwards. So subtraction actually makes me think, okay, I'm going to shift to the right. So right, what's happening right now is we're shifted to the right pi over 2 units. So where cosine would normally have started at 0, 1, we're now over here, right? We're 1 pi over 2 to the right of that point. And again, we would go 2 pi down the road. So 2 pi plus pi over 2 is my next maximum. Halfway in between, we would have been down here at a minimum, right? Again, we still get that same shape, only everything is shifted to the right. We call that a phase shift. We've taken the full phase, right? What would normally have been 0 to 2 pi is now pi over 2. Essentially to 5 pi over 2, right? Everything's pi over 2 to the right of where it used to be. We're just a little to the right. Almost looks like a sine graph, doesn't it? Would have started at 0, 0. Again, being the same shape, that's where that can get a little confusing. But again, a phase shift moves us to the right or left. Again, endpoints being whatever that phase shift is. Normally we would start with a y-intercept, but we're going to move right c units, right? And again, normally we'd say go pi or 2 pi over b, 1 period down the road here. Only we're going to add that c value, right? We're going to shift that endpoint as well. So let's take a look at a couple examples very quickly here. Let's see if we can't kind of go through them kind of quickly. Again, the A value would have been what's multiplied in front. So right now for us, that's a 1. B value, again, also multiplied inside of our function. Now you'll also notice B is always factored out. Keep that in mind. So again, it would have been what's in front of the parentheses, but inside the sign, also right now going to be a 1. That just tells me, again, A was an amplitude of 1, and period, 2 pi divided by B, or basically 2 pi units. Where C and D come into play, well, again, C was what was subtracted on the inside. Notice again, it's x minus C in our formula. So again, this is pi over 3 units. Then D would have been what's added on the outside. So again, that's that negative 2 value on the outside, essentially shifting us down 2 units. Well, remember that sine starts at 0, 0, so the amplitude in the period never really changed that starting point, but we are going to shift again to the right pi over 3 units and down 2 units. That negative 2 is going to change our equilibrium, so I'm going to go ahead and draw a line down here, a horizontal line. It's going to help me sort of center my graph down below there. And then again, I'm going to remember, well, hey, I want to start at pi over 3. But then I want to count out 2 pi. Well, I'm going to think of that as something over 3. Well, 6 pi over 3, right, would be 2 pi units down the road. So again, I want 7 tick marks, and I think I have just enough there. If I call the first one, again, pi over 3, then I can go 6 more tick marks down the road, right? 6 pi over 3. So 1, 2, 3, which I'm going to go ahead and put a point on. 1, 2, 3, right there. So this would be at 7 pi, right, over 3. And again, I want to start and finish in the same place, halfway in between. I'm going to be back on equilibrium again, which actually means I put those 3 points in bad spots. Let's go backwards here a little bit. I apologize. Remember that my points need to be on equilibrium, right? They needed to be 2 units downward. But again, this is still going to be at pi over 3 and 7 pi over 3 to finish. But we need to be down on equilibrium. Then we have an amplitude of 1. So now I can go back to my period and amplitude and say, okay, well, halfway in between those, I want to be up 1 unit. Now notice that's not right on my tick marks, but that's not a big deal. And halfway in between again, I want to be down here 1 unit below equilibrium. But my entire graph is going to happen below the x-axis this time because of that shift, right? Because of that shift that we had going on there. Let's take a look at another example. Again, A would be multiplied in front, B multiplied on the inside. Notice nicely factored out there. C would have been added or subtracted, if you will. So C is going to be a negative 1 this time because, again, it's showing addition. And D, again, plus 1 on the outside. Amplitude, therefore, is 2. Period would be 2 pi divided by pi over 4. Well, the pi's are going to divide away. And again, if you divide by a fraction, we multiply by the reciprocal. If you do a little arithmetic there, looks like we're going to be at 8. So this will be kind of nice. We get to count by whole numbers. But again, the sign normally starts at 0, 0. We're going to start at negative 1, 1. We're going to shift down 1 unit. So again, I'm going to draw this nice equilibrium line here. And then we're going to shift, oops, not down 1 unit. That was C, right? Yeah, we got to back up there. Sorry about that, making a few mistakes. You're probably going, well, does this guy even know what he's doing? Well, he does. D equals 1, right? Again, that's our equilibrium. That's our shift up 1 unit. Then C is going to be shifted to the left 1 unit. So again, we're going to start at negative 1, 1. I'm going to go 8 units down the road. So now, nice far as we can count by whole numbers. That means I'm going to go to the 7th tick mark, right? Negative 1 plus 8 would have been 1, 2, 3, 4, 5, 6, 7. So again, that's down here. Halfway in between would be 4 units. We're basically at 3 here. And then halfway between those, well, between negative 1 and 3 is 1. But again, I need to be up 2 units in amplitude. and or down 2 units. So down at -1 here, right? But 1 minus 2 from y equals 1 for that red line down 2 units. Again, we're going to be below the x-axis this time. So again, curving up that way. And again, one full phase of our graph. Centered at D, right? That's our equilibrium, right? Y equals 1 was sort of our equilibrium this time. But again, we're 2 units up and 2 units down. That's our amplitude. And we're a full 8 units, right? Left to right. That would be the period. Let's do one more quick example. Again, here's a cosine. Now, the first thing I notice about this cosine is that that inside portion is not factored. So the first thing I'm going to do is factor that 2 out. So 2x divided by 2 is x, and pi divided by 2, right, is what we're left with there. So the a value out in front is a 1. Again, there's nothing added outside. Equilibrium is going to be at 0. Right? B value, again, is at 2, which just tells me the period, 2 pi over 2. Period is going to be pi. And again, C is a negative pi over 2, because inside the formula it says plus pi over 2. So instead of starting on the y-axis, again, we're going to shift to the left pi over 2 units. Now the cosine, normally I would say, okay, well, hey, we didn't shift up or down. The sine value wouldn't have gone anywhere. That would be 0. But remember, the cosine starts at a maximum. And with a being 1, know that the amplitude is 1, we're actually going to start up at 1. So now I'm going to go with a period of pi. Now notice if I go negative pi over 2 is half the period. Pi over 2 is a half pi. That's half the period right now. So again, I'm going to go a couple of tick marks over. I'm going to call this negative pi over 2. 1 full pi. Away from that would be pi over 2. So again, if we start at negative pi over 2, 1, right, if we call that 1, we're going to finish at pi over 2, 1. On the y-axis, we would have been down at negative 1. And again, halfway in between, or at those pi over 4 marks, we would be right there. Again, a full distance of pi. We're up in 1 and down 1 unit, amplitude of 1 from equilibrium right on the x-axis this time. And again, I hope that helps you understand. This can also be confusing. That almost looks like just a negative cosine, doesn't it? Again, starts at a minimum, and maybe the period's off a little bit, so again, we would have to change that. But again, these can be somewhat confusing if you're looking at the graph. That's why those details matter. Make sure you show the analysis. A, B, C, and D. Identify the amplitude, the period, and a good place to start. Always a good idea when you're graphing a periodic function. I hope that helps you graphing sines and cosines. If you have any questions, talk to your teacher. Otherwise, have a great day.